Hi, I'm John Derry, a senior application engineer with Promess Incorporated,
And I'm Peter Parsons, just a normal applications engineer at Promess.
and we're here today to present a webinar that is based on our Promess Workstation and how it can be used from prototyping all the way into your production.
We're going to be playing a pre-recorded video for you that goes over our different types of workstations as well as detailing the process from prototype to production.
We also have a downloadable flyer that can be used as a supplement to this webinar. You should see it on the side of your screen.
If you have any questions at any point during this webinar, please put them in the chat. After the video is ended, we'll be getting to your questions and answering them. Welcome to the Promess Workstations from Prototype to Production webinar. Today we're going to be talking about the Promess Workstations, which is an off-the-shelf turnkey line of products utilizing our servo technology, such as our presses and torque units.
Promess is the world's leader in servo and measuring technology. From automotive components to medical to aerospace and consumer goods, we help out all over the world assembling better components.
Using our pressing and torquing technology, we initially came up with the idea of the workstation to assist us internally in helping to create processes for our customers. By using our products in a standardized, self-assembled area, we're able to get a lot of different functionality out of the workstation, being able to use it for multiple different iterations, programs, and whatever needs were needed for that specific product.
After our customers came to Promess to utilize our original workstations, we got the idea to develop a lab on our campus that allows our customers to bring their components to us and assemble them to verify their processes, verify quality of the initial components, allow faster prototyping. Eventually we started calling this lab the Process Development Center. We have multiple different workstations available for customers to use, and we also supply all of the data from the parts that we run to our customers, so they're able to make better choices moving forward.
And to show you an example of what the typical process of using our Process Development Center looks like, we've put together a video for you to show what that looks like. Enjoy. We're at the Process Development Center at the Promess headquarters located in Brighton, Michigan, where we are going to be doing some customer testing.
Yep, today we're going to be doing some part testing on a customer supplied cylinder made out of steel. We'll be pressing in polymer inserts. We'll be monitoring force and position to determine if these parts have been assembled correctly. We will then analyze the data using our UltraPro software to let the customer know which parts are good, which parts are bad, and what might need to be changed before these make it to production. Today we'll be using our Size 1 workstation fitted with a 12 kilonewton electromechanical assembly press.
All right, you ready to begin?
Absolutely, let's get started.
That was 30 cycles that we just ran assembling our customers' parts. Let's take a look at the data.
Yeah, let's review.
Here we can see the graph of each cycle as well as the data saved during each cycle. Using the data utility, we can compile all this information into a single table, which can be exported as a .csv file. Additionally, we have the ability to overlay the graph of each cycle to compare them against one another.
In the overlay we have in front of us, we can see that 3 parts look drastically different from the remaining 27. The part that Peter just highlighted, you can see had a higher running load than all of the other parts. This might mean the interference fit or the nominal ID-OD interference is too tight for what the customer is expecting. We can also see 2 parts that have very different final positions from all of the other parts. This might mean that the linear stack up is too great in these parts, thus making the final position shorter.
From this overlay, we're able to see what a good part should be based on an average of these cycles. Now, what you just saw in that video is the typical process when going through our PDC, when running your parts through and having us test them. Now, as you saw, we tested 30 different parts, and from that, we were able to gain a pretty decent understanding of the limits and parameters that that part can hold, which can help us to assist the customer in best creating the best process for that part.
Typically, our customers want to be on site to help us with the testing of their components. When that's not possible, we ask that they send in a drawing or spec sheet to allow us to understand what criteria of the part is important to capture and what the limits of the parts are. So we know how far to press the part, how much force to put on the part when assembling them, and what kind of dictates a good part versus a bad part. Ideally, customers would be on site to help with that testing. With their eyes and knowledge of their own components, it's vastly superior to just us doing it. But it gives us kind of more of a on-the-fly ability to adjust the program as we go, rather than running the 30 cycles as we see fit versus how they could help with that.
Exactly. And as those customers are in the PDC watching this process being developed, they're also familiarizing themselves with the software and the technology that they'll be using in their production lines. So going through this program that we're creating, they're able to get a good idea of how everything's coming together, and if changes need to be done further down the line, they already have that base knowledge of how that program was assembled.
Absolutely. We like to think of the PDC as allowing our customers to test drive Promess, not just the technology, but Promess as a company, seeing how we interact with our customers, the relationships we develop, as well as how we can help them improve their process, both in prototyping and in production.
Exactly. By using that same technology for both the development and the production, there's a lot of information that gets retained between those steps, saving a lot of time and money.
We're able to catch things earlier, maybe prove out good parts and bad parts much sooner in the process, and also compare more apples to apples, the data. So the lessons learned on a Promess workstation translates directly into production rather than having to prototype with something else and then maybe move some of that over.
Exactly. And so in this process of offering our process development center to customers, many of them saw these workstations we were using and saw that as a product that they wanted to have in their own personal development lab, which is what led us to creating these workstations as an off-the-shelf turnkey product that's easily integratable in almost any lab, any production floor, anywhere where that need is. Really all you need to do is provide power to the system and you're ready to program.
Yep, as Peter mentioned, once the system's powered up when you purchase a workstation, you're able to install your part-specific tooling and fixturing and pretty much get right into programming. And if it's something that you've programmed at Promess previously, we're able to provide that part program or the functional movements of the press as well as the data acquisition, which speeds up the prototyping further. A lot of our customers saw the value in using the PDC, but wanted a way to be more agile and swift with their prototyping. And purchasing a workstation directly from us to use in their lab allows them to make quick on-the-fly changes or maybe grab different bits of data that might be important as different things arise.
Exactly. Ultimately, they'll be the ones with the production line, so the more that they can get involved in that development process and the more that they can have that same technology starting at the ground floor, the better.
Definitely minimizes risk and avoids surprises unnecessarily later down the process. And using our monitoring strategies, we're able to help the customer determine if there might be an issue upstream as well on the subcomponent level before it even reaches this prototyping station. And that's one of the biggest advantages over using something like an arbor press just to push some parts together.
Yeah, definitely. So not only are these workstations capable of being able to develop processes for hundreds of different components that might be ran through a certain company, but additionally, these workstations are highly adaptable to meet any needs that the customer might have. Oftentimes, customers will integrate external load cells into their workstations to be able to have varying ranges of force depending on the size of the press. Where you might have a press that has a range of 120 kilonewtons, by adding an external load cell to the workstation, you're able to have a much higher accuracy at a much lower range.
Definitely. We see that all the time where our customers have a range of components they need to prototype or assemble, and adding an external load cell essentially makes one press into more like two presses, where you have two usable ranges without sacrificing accuracy on either. We see this all the time in automotive, especially where they might need to prototype a small part like an electrical board or a large part like a differential or something like that, an electric drive unit, with these EDUs becoming more and more popular.
Yeah, definitely. Whether you're pressing compliant pins or if you're pressing a bearing into a shoulder, um, having that adaptability in the workstation saves you the need of having to prototype on multiple different stations and having a wider range of technology than you might need if you have one of our workstations where it's all bundled together and able to be ran in the single unit.
Absolutely. And the workstations that you saw in the video were our standard C-frame workstation. The workstations come in a variety of sizes, shapes, and different functions. The C-frame is the most common, but we also offer a four-post design, which gives you a little bit wider area to press on, and they're a little more user-friendly when you need something like T-slots. We also offer a gantry workstation, which is pretty exciting and new for us. That allows the press to be moved anywhere within the pressable surface of the workstation. It also allows you to bring the press to the part rather than having to shuffle the part underneath the press or develop different nesting depending on which part of the part you're pressing on.
Definitely. And with that gantry workstation, you have the ability to simulate multiple different presses within a same area. Whereas in the production line, you might have 4 different presses. By using a gantry workstation, you can emulate those 4 different press positions on a single part in that single area. Additionally, besides the gantry, we also have a torque table, which uses one of our torque pros. So instead of a linear force, it's able to provide a torque in a workstation form.
Yeah, we've definitely seen an uptick in the need for a torque workstation as running torque and breakaway torque become more and more important as efficiency standards keep rising, especially with EVs and EDUs and more efficient bearings being required. The Torque Pro workstation allows you to couple directly to your component, fix it to a base, maybe measure running torque, breakaway torque, things like backlash, maybe torsional stiffness even.
Definitely. And aside from the Torque Pro, we also offer workstations using our remap, which offers both the linear and rotational force and torque capabilities. Oftentimes, if pressing something like a gear, where there's a set rotational position that a part must be set to, you're able to press down with a force as you're rotating to allow for the compliance of that part to fit.
We've also seen a lot of customers use the remap workstations for bearing drag torque measurements. As EDUs become more popular and electric drive units, we see customers requiring more and more efficient bearings. We're able to gauge this efficiency by applying a linear load while rotating at a set frequency. And we should see an increase in linear or torque as that linear load increases proportionately. That helps our customers select the best components to put into their assemblies.
Yeah.
The workstations can also be loaded manually, so an operator could load and unload. They can also be loaded in an automated fashion, such as a robot or a conveyor. We work with a lot of integrators closely to be able to use things like collaborative robots or smart conveyors to load and unload. Another way we can load and unload is a Promess supplied index table.
Yes. Our index tables have a rotational base where parts are able to be loaded and then rotated under the functional area of the press, which oftentimes I've seen integrated with robot loading, where a robot is able to set a part in place without necessarily working its way too far into that workstation's functional area.
And I think that goes back to the whole point of this webinar, is that these workstations can be used from prototyping all the way into a production type environment where you would be loading it and unloading it with a robot. Another thing that we take for granted sometimes is our benchtop workstation and how compact and functional that really is in such a small package. We're able to get all the electronics and safety that a traditional workstation has in something that could fit right in front of us on this table here.
Definitely. And with our benchtop workstations, there's a lot of different configurations that we have as well, such as the L-frame benchtop workstation. It's not necessarily bound by a confined enclosure like some of our other workstations might be. In this case, instead of using a light curtain for a safety feature, we are using a two-handed tie-down, to keep the operator's hands within a set area, which allows you to press some abnormally sized or extremely large parts using this workstation.
Yeah, and all of these workstations allow our customers to be more efficient, save time, save money, and minimize risk. They're able to prototype and move that same process over to a production environment.
Exactly. This is the technology that will be in your production lines, so why would you not want to start using and learning that technology as early as you can from the ground floor in that process?
So with all that being said, we'd like to offer everyone watching the time to ask us some questions that we can answer for you.
Welcome back. I hope you enjoyed that video. And if you have any questions about anything that we shared with you, feel free to put those in the chat now, and we'll be able to answer those.
All right, it looks like our first question came in. It's asking, do you offer custom workstations if our application does not fit within a standard size? So the easy answer to this is we don't necessarily call them custom, we call them tailored workstations, but we're happy to meet with you and discuss your needs to see if we can accommodate whatever part size you might have.
Another question here. How big of a press can you put on a workstation? Similar to how John was saying, we like to offer tailored workstations. So a follow-up question to that would be, how big of a press do you need? If there's a certain need, we'll be able to work with you to see if we can offer a solution for that specific need.
All right, it looks like a third question popped up asking, what is the current lead time for a standard workstation? So the current lead time for a standard workstation is anywhere from 16 to 18 weeks. If there are needs that might be a little bit faster than that, feel free to reach out to us and we'll see how we can accommodate that as well.
All right. Looks like we have another one. Other than your standard workstations, are there any means to integrate more mechanical options, manual and auto loading? So definitely, if there's any kind of need, anything specific, such as manual loading or auto loading, by working with us, we're able to kind of develop solutions tailored to that need, similar to how, like our rotary, the index table on our workstation, you're able to load a part into that and have it automatically rotate underneath the press, integrating that with a robot to be able to load a part into there.
As Peter mentioned, we're able to integrate some more advanced manual and auto loading features. In the past, we've also worked with other machine integrators for more complex solutions. So that's always an option as well.
All right. Do you have any more questions? Looks like we've got one more. What cycle time does a workstation have? So that's really going to depend on what the application is, on what exactly you're pressing. Most of our presses typically can run at a speed of about 200 millimeters a second. So depending on what you're pressing and how much force you need, that cycle time can vary wildly. But
all right, it doesn't look like we have any more questions. If there was anything that we missed, please feel free to reach out to us at sales@promessinc.com or 810-229-9334.